folks, and welcome to Great Chesterford Junction Model Railway. This time we're talking about my magnetic coupling system, and I'm going to take you through how I actually build these couplings. But first I think we should talk about standards that we have to sort of meet to make this thing work properly. So there are certain bits of geometry, I suppose, that we have to understand first. So let's have a look at that now. Now there's a couple of categories that we've got to look at, and probably the first and the most basic is just a four-wheel wagon, a two-axle setup, where you don't get very much movement of the body of these wagons through a curve. However, the couplings need to be set up so that you have a reasonable range of movement there. You can see the magnets all let go now, but you need that range of movement like that to negotiate even the tightest curves. So you need plenty of play. What you don't tend to get with these wagons is this sort of sideways movement, but you just need a little bit there, and you can see that these couplings are actually limiting how far these wagons can move in that sort of plane. So you need restricted movement in that regard, otherwise they'll just fold up completely on each other and then there'll be buffer lock. So the reason you've got that limited movement there is to stop buffer lock. When it comes to a bogie wagon, obviously the bogie can move independently, and with a bogie wagon you're getting this swing created by the body through a curve, especially in S formation. So therefore we need to counteract that by not mounting to the body on anything with a bogie, but rather mounting to the bogie itself. And you know, each wagon will probably have its own sort of needs in terms of how you set it up. But with a bogie wagon, you get this extra movement between the two wagons. However, you're still reaching the limits here where you don't get buffer lock, because the four-wheel wagon on the left is sort of keeping this bogie in check and preventing buffer lock, so the two can push together. You've got the good range of movement again through the curves in that sort of arc, so that all works fine. So the next thing is I'll show you two bogie wagons together. Okay, with bogie wagons, it's important that when you get to this sort of movement here through an S formation, that the couplings that are joined together can keep the two wagons apart, which is what they do here. You've also got a good range of movement that way and that way, so you've got quite an extreme angle there where it will work. Of course, the same principles apply to locomotives as well. A little tank loco like this, you will get very little movement at the ends of the body of the loco through a curve, because it's so short. It's pretty much the size of a four-wheel wagon. However, if you took something like this prairie here, for example, now the main driving wheels are sort of centered here on the prairie, and so as it goes through a curve you get a bit more swing at the back than you would on a smaller tank loco. So you've got to think here how you approach the coupling, whether you go onto the pony truck, which is, it's okay, but you know, the pony trucks are usually very light, so you might need a coupling on the back of the loco with a lot more range of movement in it, and that will deal with the swing of the body. Yeah, so when you get to a diesel like this class 33 here, I mean, bogie at each end, and obviously you've got body swing. It's not too bad actually on this locomotive, but what I've done here is I've put a sliding ring, which you might have seen on one of the other videos, to allow the coupling to slide across in a wide arc, and this works quite well with this locomotive. So each locomotive will have its own sort of demands on the system, and each one has to be looked at realistically and to work out how coupling is going to be fitted to it. I guess the basic system on four-wheel wagons is a piece of cake, but when it comes to bogie wagons, you've got to try and work out a way to fit the coupling to the bogies. There's no point in going to the bodies on bogey wagons. Tried that many times, it just doesn't work, folks. It pulls good, but it won't push. Well, it will push within reason. I mean, if you put it through the most extreme S formations of track, it doesn't work. But on a straight push, it's probably working okay. So yeah, it depends on what track you've got. I've got some tight radius pieces of track here on Great Chesterford, and yeah, it's just not going to work satisfactorily for me. It might work for you. Anyway, let's go and have a look at how we set these things up and get into it. Right, folks, all my couplings now are made with these little suckers here. This is part of a hook and eye set, and these are made by Birch, the ones I've got here in Australia anyway, and it's the sort of connections that you will find on clothing, particularly on bra straps and that sort of thing. And I'll show you the packaging for this so you know what it is. Right, you can see that these are made by Birch. They are 9mm, which is size 1. If you don't have a measurement size on the packaging that you're looking at, you can go by the size. They go 0, 1, 2, 3, 4, I think. 1 seems to be good. I think the 0 is probably a bit small for me, and 2 is probably too big. So they're called hooks and eyes, made by Birch, rust-proof brass, which amazingly is attracted to a magnet for some reason, even though it's brass. And you get a package there of 12. There's 12 hooks and 12 eyes. So what I'm using are the eyes, technically. The hooks I'm just putting aside. I should say that these things are, I'm picking them up for $3 a packet on eBay. So there's not a lot of money involved in this. The other thing I'm using is these circular neodymium magnets. They're 3mm by 1mm thick, and I think they're N50s actually. I've had them for a while, but they're N50s. The other key element in this process is this wire that I use. I've used this in the past to make fencing, etc. You've probably seen a video that I did on that, and this has got 25mm squares in it. And I basically cut a cross out of this wire, and that becomes the T-piece that actually holds the coupling into the buffer beam on the wagon. I've also made some jigs. You can see that this is a piece of Perspex with one of the neodymium magnets in it, and what's happening here is that I've marked one side red and one side white, and what I do with my wagons is I've set them up wagons that, let's say, have a positive polarity. They'll have the same polarity at both ends, and I'll call those an A wagon, if you like, or the white wagon. And the wagon that goes next to that will be the B wagon, which will have the same polarity at both ends, and that'll be done with the red marking there, the red polarity. So the wagons, each wagon can be turned around in any direction, and but it does need to connect to its opposite polarity. So instead of having opposite polarities on each end of the wagon, I've gone for having each wagon with the same polarity so that the wagon can be rotated. So this is one of my shunters, and basically it's got a coupling without a magnet on it. So it's got material on here though that is attracted to a magnet. So it doesn't matter what polarity of wagon it comes up to, it will always connect to it, which is good for shunter because it won't be dragging long trains, and it won't be dragging long trains up inclines or anything like that. So it can deal with quite a few wagons in a yard and move them around, and there's no problem with polarity. I'll just zoom in so you can see the coupling a bit better. Now what I have here is a very small split pin, which is inserted into roughly the buffer beam on this loco, and here is a bent over, let's see if we can connect to it, a track pin that's been bent over, and it's got a nice flat head on it, and that will swing up and meet the magnet on the wagon and connect to them. So there's one of those at each end. They have to be set out pretty much in line with the buffers so that when they get close to
the magnet on the wagon that's opposite, they will easily swing up to meet it. If you set it too far back, it doesn't work as well. So if we turn it around, I'll show you the back. Yeah, similar at the back there. You can get a good view. I'll just pull the little track pin out again. There we go. Move the camera back. Yeah, so that's quite effective, and that'll move 8 or 9, 10 wagons easily around a yard. Okay, back on to jigs again. This is a piece of aluminium flat bar, and it is 3mm thick there. The width doesn't really matter in this case. The important thing is that it's 3mm thick. And when I make the little T-piece out of the mesh for my coupling, the little T-piece that holds the actual coupling, I push the arms of the T through this 3mm flat bar and snip them off here to get the same sort of distance each time. So it's 3 mils each side. However, there's another piece on the T-piece that actually hangs down to prevent the coupling from sort of swinging back under the wagon and being attracted to the actual wire. And so I've actually had to make that a bit longer, so I've got a nut super glued on here to give me a bit more length. So I put that particular piece through here to trim that off before fitting it all onto the wagon. Another important jig is, this is actually a height jig, and it's quite simple. It's a block of wood here, and I've got a nail, a sharpened nail actually, that protrudes from here, so that what I can do is wheel a wagon up to this point here, a wagon that's been prepared and ready to have the new coupling fitted, and this point pushes into the buffer beam, and it will establish the same height of coupling each time a coupling is fitted, regardless of the setup on the wagon itself. Some of the older wagons are a bit taller than some of the new wagons, and you get variations through different brands of models. So this will attempt to establish the same coupling height each time. So the idea of the point is to make a mark on the buffer beam, and I can drill a hole through there. So this is an old piece of test track that I've had for a while, and I've just added this jig onto it just today actually, and I think it's all part of the standardization with this system. If you're going to do it, you might as well do it properly. So the ones I've done so far are pretty close. They're within the ballpark as far as the measurements go, but now everything will be set up exactly the same. Now, to actually create a coupling, one of the first things I do is I take one of these little hooks and put it in a pair of pliers so that just the little rings, I'm sorry you can't see this very well, but until the little rings are just sticking out of the pliers. So we get it like that. I'll then hold that pretty tight and take another pair of pliers. Hang on, I think that's moved on me. No, it hasn't. No, we're good to go. It just looks different when you look through the camera. So take another pair of pliers, and we've got to give these little rings a turn through 90 degrees. So we just turn one, and then we'll turn the other one. It's a bit tricky doing this, folks, with the camera in the way. Right, got them. And now I just make sure that they're sitting parallel to each other, and also in that plane as well. So we then finish up with a coupling like that. I'll then put my jig for the magnet in the vise, and you can see this is the A side magnet. What we're actually doing this time is a brake van, and I think I neglected to mention, with brake vans I'm doing an AB setup on a brake van, where the front of the brake van is A and the rear of the brake van is B. This works out much better in runaround situations if you're going to a branch line terminus or something like that. So brake vans are dual polarity. Yeah, so we set up the jig in the vise, and then I'll grab a magnet. Well, I just bring the magnet to the jig and it will find itself sat on there quite easily. So what we do then is we bring the coupling to the magnet, and in most cases, folks, these things will stand up for you on the magnet. Now what I've been using, folks, to hold these two parts together is UV glue. And the first thing I'll do is put a blob on there and then get straight onto it with the UV light, and I do about 20 seconds each side. Now I just slide that off there with a knife, and you can see it jumps straight on there. It saves pulling it, just in case the glue's not set properly. It holds it really well. I'll then transfer the coupling to another jig, which is basically just a nail, and I've ground the point off it and got a flat head on it. It's just a simple way of holding the coupling while I add some more UV glue to it. So this time I go down to the magnet itself and the edge of the magnet, put some on the front, and then UV glue for 20 seconds, and repeat this all around. So we'll do the front, the back, and then the two sides the same way. And this just ensures that the UV glue is grabbing down the sides of the magnet as well. And yeah, I've tried it with just the one blob on the top, and it doesn't hold it well enough. But this way it forms like a glove over the magnet. Well, we've got the coupling on the end of the nail there. We just and the glue's dry, of course. We come in with a Sharpie marker and just blacken up the coupling. Looks better that way. You don't have to do that, but yeah. So she's all set to go. Now I've cut a cross shape out of some of the wire mesh, and this is just rough at the moment, but we'll assume that this is the stem that will go into the buffer beam on the wagon. This is the cross piece, so they'll have to be trimmed down each side to 3mm, and this will be a long piece which will be folded over to form a let's say a stopper, so that the magnet on the coupling can't go too far back under the wagon. The tendency, it depends how the wagons are set up, but a wagon with no obstructions, no plastic obstructions underneath it, now the magnet will try and be attracted to this part of the coupling here. So I found the way around that was to have this piece that's folded over at the front and angled back, and that stops it going back too far. And actually you can even move it further forward if you want to have a better attraction to the shunters coupling, etc. So what I'll do is put this in the vise now, and I'll bend that over, and then we'll trim it off. So I just put it down in the vise so that the T-piece is just below the surface there, and then I get a small hammer. Well, I can actually bend it over with my finger initially, but I just get a small hammer just to give it a tap and make sure that it's at a nice sharp angle there. Okay, so we've had that in the jig now, and we've trimmed it all up to its final sizes, and I'll just give this bar here a bit of a bend back to about 45 degrees, and we can do final adjustments on that once it's actually on the wagon. So we'll just give that a bit of a bend back. So yeah, it's about 45 degrees. something like that. But as I say, that will be adjusted. We don't want it too far back, because when the shunter comes along you won't be able to connect properly. But anyway, that's that bit for the moment. I've blackened the T-piece up with a Sharpie pen, or any felt pen will do. I've tried paint in the past, and I find that paint is a bit too thick. It just gums up the works, and you want these things to swing freely. So yeah, something very thin is better. Right, it's now time to fit this little coupling onto the T-piece, and I use these jeweler's pliers to spread open the jaws of this coupling, because the magnet is attracted to one side of it, and then you can put each side of the jaw around each side of the opposite thing here, and when you push in it spreads the coupling apart. So if we have a look at that, we'll just, as you can see, it's it fits on one side there, and just push the jaws together like that, and it opens out the coupling. So we'll just give it a bit more, push it down a bit further. I usually find you've got to go all the way to the bottom, and that's opened it out fairly well. And we'll just bring the T-piece over and put the two together, slide on one side then the other, and then just squeeze the parts together. It's a fiddly job. Now they should go together so that when they move from side to side they won't come off. So that's done. Now there we are there, and you can see the retainer there. It stops it going all the way back. Now this coupling is going on to a brake van, and remember I said that brake vans are the AB setup, so I consider this the front of the brake van and that's the rear. So this will be a white coupling, and this will be a red coupling. So this one is fitted, like the holes have already been drilled. I've removed the old couplings. So all I'll do is I'll do a test fit and see if I need to trim anything off this coupling that I've made by pushing it in first and seeing how far in it goes. And actually it's not going far enough in. I'd like it a bit closer to the buffer beam than that. So yeah, you can see there. So I'll take it out and trim a bit off, and then we'll put it in. Now to fit it to the wagon, I hold the working end of the coupling up and the shaft down, and I put some super glue on the shaft, and the idea is the super glue doesn't run towards the coupling, it runs away from it. And then we push it into the hole in the wagon and make sure it goes in far enough so it looks good, and it's also level, and also that there's enough space between the coupling and the buffer beam so that you can get movement in the actual coupling itself. So we'll just let that set and we'll come back to it. Okay, time for testing, folks. So what we'll have to do is bring a red wagon up to this, because we've got white at the front here. So we'll bring a red one up. And there we are. Just push those apart. Do that again. Yep, that's good. So now all we have to test is the shunter, so I'll bring that over. Where is it? Here we are. So again with the no magnet on the shunter, so yeah, that's good. I'll just try the other end. Yep, got it. Now what I'll do with this wagon, folks, is I'll just put a dot of white on the axle box here on both sides to denote the front. And we'll do the other side. And we'll leave that to dry for a bit, and then we'll do the same process on the other end of the wagon, only it will be a red polarity. Okay folks, the other end of the wagon is done now and tested and working fine. So that's the end result. That's not a typical wagon, but it's a brake van which has got the dual polarity. But I think these couplings, even though they're a bit crude, are a bit of an improvement over tension locks. We've now got consistent coupling, and yeah, uncoupling's considerably easier. If you've got mixed tension locks, it's a bit of a nightmare. So they just come apart. Yeah, you can push them apart by hand, just like that. Yep. And if we lift this particular wagon, which is the red polarity and the bogie as well, and turn it around, and when we get to the other end, no problem. So there we go. Now with locos, you can't necessarily always use the same sort of system, and the locos are going to vary. I mean, with a little tank loco, you could get away with it, where you don't have much body swing at all. But what I've done on this particular one, this Lima Prairie, is added a slight variation on the coupling. So if we separate the two here, we'll see better what we've done here. Yeah, this has a link out of a chain. That's an iron core chain, and it's got the magnet glued to the bottom of the link, as we've done previously. And on securing it to the buffer beam is a miniature cotter pin. And this allows a lot of movement in each direction, and sort of counteracts the body movement in the loco. And because it's always going to be connecting up to one of our couplings that has the restricted movement on the wagon sort of transfers across to the linkage on the locomotive, and therefore it won't travel too far going through an S formation and create buffer lock. However, it will push properly through the formation. So it just depends how much sway you've got in the locomotive body, and once you get into diesels, etc., it might be necessary to mount the couplings off the bogies. So it's very much a matter of suck it and see how it pans out. You can see I've employed the same method here on this little tank loco, and because of the length of the buffers on this auto coach, when you get into a tight curve, you need a fair bit of room for the two vehicles to sort of bend without getting buffers touching or buffers locking. So I've used the link system on both of them actually, but I've got one turned one way and one turned the other way, so that when they're pushing, they won't try and go too far one way or the other. So you can see that one's rotated 90 degrees different to the other. and this seems to be reasonably effective in this situation. I don't know how to go pushing a full length of train, but and also we've got the coupling mounted to the bogie on this particular coach. And seeing how it's only ever going to be one coach, I think we'll probably get away with that sort of system in this situation. During the process of converting my rolling stock, I've used this wagon as a bit of a stopgap measure. We've got the new coupling on this end, and on this other end I've got a tension lock. So in theory I can pull two types of stock with this particular wagon. Eventually this will go over to complete conversion. With this southern engine I had to take a different approach altogether, although this was early days, and I think that probably I could get away with the cotter pin and the link system on here, but this was an adaptation of the T-piece, and I put an arc in it, and I made a jig in a bolt to actually create that shape. But it actually improves the range of movement, and which is quite good. And you know, the body on this loco doesn't move that much, and and at the back end, of course, the tenders don't matter so much, because the tender basically is like a big a wagon as far as swing is concerned, but there's one on there as well. And yeah, and that works quite effectively. So yeah, it needs a bit of lateral thinking when it comes to locomotives sometimes, because they're all different. Basically, most of them, unless it's something really huge, you can get away with using the buffer beams. For example, this Ginty, I mean, that's no problem at all. I would put probably a cotter pin system into the buffer beam here. This locomotive's been the subject of quite a few conversions. It's been a bit of a guinea pig, but anyway, I think a cotter pin with a chain link and a magnet would work perfectly fine on this locomotive. Yeah, so yeah, it's horses for courses, folks. But generally the main thing is that for the overwhelming majority of my rolling stock, which is wagons, goods wagons, it's going to work with the method I've shown you just earlier. I have also converted a couple of coaches, and coaches have to be worked off the bogie, and so I made a little arrangement here with bent wire, which is brass wire actually, and put a loop in it, and so that's got a chain link as well, and the magnet. And because generally coaches are not being sort of shuffled around, pushed around, they're usually in the pulling situation, I thought, well, I'll get away with it on this. This is just a 2-coach set. I've left the tension locks in the middle, and so that connects up to that Lima Prairie I showed you earlier, and that's quite effective. So plenty of range of movement, and because the coupling is connected to the bogie, there's not going to be any sort of excessive body swing to deal with. So this works quite well actually. The beauty of this is compatibility, and I'm not worrying about will my coupling fit the other coupling, a new one and an old one, and they have reasonable strength. You can see I'm pulling on the wagon here, and it's pulling the locomotive, so if I give it a bit of a jerk it comes away, but yeah, they've got a good amount of strength in them, these couplings. So yeah, so I've just got to pursue the rest of my stock and get it converted over. This is a jig I've made for the curved T-piece that you saw on the southern engine, and it's a matter of mounting this in the vise and then bringing the T-piece or the wire to it. And I've also created a former with a piece of wood with a slot cut out of it that pushes around the wire and around the bolt and makes sure that you get a nice shape every time. For these particular parts I would probably trim them off to the longer length in this situation, because it's got to go around a curve, and yeah, it just gives you more room to play with. So we just take the T-piece to the jig and hold it tightly with a pair of pliers, bring the wood to the front and just push, and then we can lift it off and remove it from the jig. We'll need the pliers to do that, and there we have our little piece.
So you can see, folks, it's not just a very simple system. You need to be able to adapt to especially locomotives and wagons with bogies. That would apply to coaches, of course. But you know, fundamentally for me, most of my stock is wagons. So you know, there's going to be a lot of repetition and the same sort of process, and it's a fairly easy process. Yeah, so generally it's going to be pretty good, and I'll just have to put my thinking cap on every now and then to work out how to convert a loco over. I didn't mention also this uncoupling pole. This is just a bit of plastic recovered from an ice cream container, and it's simply got a hole drilled in one end. This is a bamboo skewer that's been adapted. It's got a V shape sort of filed in the end here, and there's actually a slot cut across here for this plastic to sit into. There's another slot back here for the plastic to sit into, so it's sitting in there under pressure. And at the end we've got a little copper ring, or it's a little copper rectangle actually, and that's glued in place there, and that's for lifting the coupling up if necessary. Most of the work is done with this end to push down and separate wagons or coaches or whatever. So yeah, that's basically it. Pretty much still a work in progress, I suppose, although I feel like I'm near the end now. As I mentioned, I sort of avoid painting the couplings because I've tried that before, and it sort of gums up the work a bit. Gums up the works a bit. So most of it's done with just a felt pen, and yeah, so that seems to do the job okay. The main thing is that it works and it's easy to use, and yeah, it's taken away some of the frustration I've had with tension lock couplings over the years. And the problem being that they come in various sizes unless you buy all new stock. The various companies that are producing these things now don't have a standard shape or height for their tension lock couplings, even though they all look similar. You'd be surprised how much variation there is in height, and that just, to me, that's crazy. Yeah, they need to get their act together and standardise those couplings and the height of them. And then things will be a lot easier, but then you'll still have to deal with the old style couplings if you've got old stock as well, or convert them over. So, you know, happy days means some sort of conversion somewhere down the track. Anyway, that's about all I've got for you today, so I'll leave it with you and I'll see you next time. Cheers, Gormo.